We've got another graph up here on the board. Here's our function f of x. Again, I'm going to ask you to pause the video and try to sketch f prime. And I've kept these questions up. Hopefully they help you in figuring out what the graph of the derivative looks like. So I've got it set up nicely so that we can sketch f prime. It's directly below f so that we can line up corresponding portions of the graph. So I start by asking up or down. So it looks like we start out going up. And we go up until we hit this asymptote. Now I'm going to just extend that as just a boundary to say that, okay, where the function is going up, I know that that tells me that my derivative has to be positive. So I know I'll be sketching things above the x-axis. Then, on the other side of that asymptote, it looks like we go down until we hit this point right here. So we're going to go down in between these two dotted lines here, so that when we're sketching f prime, we'll be below the x-axis there. Then at this turning point, we start going up. And it looks like we go up until we hit this corner point right here. And of course, f going up tells me that f prime is positive. So we'll be sketching things above the x-axis there. And then it looks like we just go straight to the right. Now that's not up or down. We're just going to the right there. Okay, but we're not going up or down. We've got just a horizontal line segment. I actually know what that means. Horizontal lines have a slope of 0. So along this section, the derivative is simply going to be 0. I can go ahead and fill that in. I'm just not going to quite get to this line because the next thing I'm going to do is take a look at my transition points. Now here, we actually have a vertical asymptote in the graph of f. So f isn't even defined there. If f isn't defined, f prime isn't defined. There's not going to be any point on this vertical line here. At our next transition point, that's a nice, smooth, rounded change. So we go from down to up, which means the derivative goes from negative to positive by passing through 0. But our next transition point was right here. That's a sharp corner, so that's going to mean that we've got a jump. There's a sudden change. And so I'll go ahead and fill in an open circle here. So to the right of that line, my derivative is constantly 0, but it's not 0 at that point. It's undefined there. Okay. All right, and then I want to ask about steepness. I like to just label, I've got two steep zones where the absolute value of my derivative is big. This would be big and positive, this would be big and negative. That means the graph of f is steep. And where the absolute value of f prime is small, which would put it close to 0 or close to the x-axis here, the graph of f is not so steep. So if I take a look, just following this part, looks like we start out pretty steep, we get less steep, and then we get steep again. Okay. So I can even write in steep, less steep, and then steep again. So it looks like we're going to have to start somewhere up here in the steep zone. We come down because we're getting less steep. Now it never actually levels off. It never becomes horizontal. And then it turns and becomes steeper again. And if I look at what happens as I approach this vertical asymptote, the graph is getting infinitely steep. It's not just that the y values are getting infinitely big, but in order for it to do that in this finite horizontal space, it has to get infinitely steep. So a vertical asymptote in the graph of f is always going to translate to a vertical asymptote in the graph of f prime. Now this is kind of interesting because this didn't have any bumps in it. It bobbled a little bit, but now we've got a bump here. If I just look at the shape, there's no reason I would think this is associated with this. I have to use this encoding of what the value of the derivative means. Okay. All right, so now we're going down, starting near this asymptote, super, super steep. So we're going to be down here, basically reading it backwards, going to the left. We're going down towards negative infinity as we approach this asymptote, as we approach it from the right. Then we become less steep, and we said we were going to hit 0 at this point. And then what happens is we're not so steep. We get steeper and steeper and steeper, but it looks like we sort of leave off at some point. Doesn't look to me like it quite gets vertical, although that's sort of a judgment call. And then we jump down to 0. Okay. If it looked to you like this was getting infinitely steep and you made this into a vertical asymptote, I think that's a reasonable reading of this. It's hard when you're just eyeballing things to distinguish between really steep and infinitely steep. Okay. So I think this is reasonable, but if you had a vertical asymptote here, that would be reasonable as well. So there's our graph of the derivative. Now, I like to have fun with these. So I like to draw these functions that aren't functions that you encounter a whole lot in the real world. There are some problems in the book where they give you the graph of a function and they ask you to sketch the derivative. But the book doesn't have nearly as much fun with this as I do. So you'll notice that in the homework, I refer you to some additional problems. And those are posted under handouts. What will happen is if you go to handouts, you can print this out, but if you don't have access to a printer, that's totally fine. You can just copy by hand. If you print it out, you're going to have 4 pages that look something like this. You've got 2 graphs. On top you've got f, and on bottom you've got f prime. This is the question. This is the answer. Okay. You don't want to start by looking at the answer. So what you want to do is you want to fold the paper so that you can just see f. Use that to sketch f prime. Then you can unfold it and you can compare your answer to mine. It doesn't need to be an exact match. We're estimating things because we're sort of eyeballing things. But your graph should be positive and negative and increasing and decreasing at the same place as mine is. It should be 0 and it should be undefined at the same place as mine is. And if you're not sure if your graph is good enough, you can always shoot me an email and have me look at it and let you know. Okay?